Hello everyone, sorry that abruptly cut off, a little technical difficulty there. So to pick up where we left off, looking at greenhouse gases, this here is a volcano which, as you can tell, emits quite a bit of different gases depending on where it is and what type of volcanic eruption it is. We'll have a chapter on volcanoes later. We'll talk more about that. It's just an example of about how greenhouse gases come from many different sources. They come out of your tailpipe, they come out of the earth, all kinds of places they come from. Um, and a little tidbit about volcanoes is although uh, greenhouse gases such as carbon dioxide that could be emitted by them make the earth warmer, all that soot can actually cool the earth by blocking the sun's rays and reflecting them back out into space. And so, if you have a year where a number of volcanoes are erupting, the average temperature of the planet can actually go down a little bit, especially areas close to those volcanoes. Excuse me. So I talked a little bit last time about basically incoming solar radiation insolation is short wave wavelengths, and so that's a good depiction there on the left hand side. And when the energy hits the Earth and it bounces off, as you can see, those wavelengths are much longer and go in many different directions, whereas from the sun's coming almost directly straight in. Um, so those short wavelengths can more easily pass through our atmosphere than the long wavelengths. It's just like inside of a greenhouse, the glass, or inside of a car, for an example. Those short waves can go through materials more easily than long waves, and so just like the inside of your car heats up, just like the Earth heats up. Um, so let's see. There's also a graph here showing the average carbon dioxide concentration going up through years. If you think about it, that's pretty logical. We're burning a lot of fossil fuels, and they give out carbon dioxide. So, it's nice to have a developing world and plenty of electricity in cars, and there are things we're putting in the atmosphere, but that's pretty obvious. So the ozone hole. This was actually a much larger news story about a decade ago. Um, CFCs, chlorofluorocarbons, are an ingredient in aerosols and a lot of products, hairspray, things like that. And what they do is they dismantle that O3 that is the ozone. Now, the ozone layer itself is one of the most protective layers of our atmosphere. It blocks a lot of the harmful ultraviolet rays that are coming through our atmosphere from the sun. And scientists began to discover that, they were breaking down. They kind of looked at, what are chemicals that we're putting in the air, what could be doing it, and they figured that the culprit was CFCs, so they became regulated in the hopes that, it'd take a long time, but that the atmosphere would be able to heal itself in a way. And it's been one of the success stories as far as environmental efforts go, because that ozone hole has begun to shrink a little bit. So that's good information, confirmation of that theory. And this is a much larger story in places like Australia, which they're getting much higher levels of skin cancer because of all the ultraviolet rays that were coming through, and now things are getting a bit better. So there's a section in this chapter about normal lapse rate. Well, what is that? What is a normal lapse rate? What does that mean? Well, let's say you're in a hot air balloon, or you have a magic carpet, right? And you start going straight up. As you go up, the temperature decreases, right? Similar thing if you walking up a mountain, right? Temperature decreases as you go up, and that's a normal lapse rate because this can be measured. For example, 3.6 degrees Fahrenheit per 1,000 feet as you go up until you reach the troposphere. So that's what the normal lapse rate is in a nutshell, and it's important to know for understanding weather that we'll be getting into a little later. Something else in a nutshell, gases that are in the atmosphere, lighter ones tend to rise up higher in the atmosphere, and heavier ones tend to be lower. Just like if you're mixing liquids together, the oil and the water will separate, just like if you're mixing rocks together in the earth. The heavier ones will go to the bottom and the lighter ones will go to the top. And yep, there'll be some mixing because, things churn up. But, that's in a nutshell a trend, all right? And you should take a minute to read this depiction. It's pretty interesting looking at the incoming solar radiation, how much is bounced off, and how much is absorbed, and how much is reabsorbed, and a lot of info there. So check that out. So another important aspect of understanding weather and climate is, well, in a nutshell, if there were no sun, let's say the sun just vanished, right? The water on the earth would all freeze, right? It'd all become ice. Because the sun is putting out energy, right? Incoming solar radiation, that's energy. Now, in order for water to go from ice to a liquid, it needs to absorb energy, right? It needs to be warmed up. Well, it's not usually the way you think about it, but liquid water has energy in it because it is no longer solid, right? So that is stored, that's hidden or latent heat. And the same happens when it evaporates into a gas. That's even more energy putting into it. So why is this important? Why does this matter? Well, in a nutshell, we've talked about states of equilibrium. So, for example, in our atmosphere, if there's a lot of energy put into a region, let's say the tropics, and so there's a lot of liquid turning into gas, right? A lot of evaporation, a lot of moisture in the air. And if you're in the tropics, you can just feel all that moisture in the air, or here in the summer for that matter. Well, that moisture, that energy, because heat rises, it will rise up because that's heat energy. And as it rises, because we have the normal lapse rate, it will cool off as it goes up. Now, as it goes up and it cools off, it will go back, right? That cooling off is releasing of energy, and so it will go back into liquid form in the form of rain, and sometimes it will go all the way back in the solid form of snow or ice, right? So that's the way the energy budget works inside of a storm or inside of larger storm systems, and we'll talk a lot more about that later. And just to recap, when we were talking about the sun's oblique rays before, in a nutshell, when the sun's in the middle of the sky, excuse me, I'm getting a cold. When the sun's straight up in the sky, it's noon, you're looking at the sun, well, you shouldn't do that, right? Because they'll burn your retinas. But if the sun is way down on the horizon, you can actually kind of look at it, right? The reason is because we're getting those oblique, weaker rays, right? And that's the reason why, on average, as you go north and south from the equator, it gets cooler, the sun's rays are more oblique, okay? So, daily march of temperature, annual march of temperature, annual lag of temperature. What does all this stuff mean? Well, it's all about insolation, incoming solar radiation. As you move through your day, right, when we talk about, around noon, when the sun's directly ahead, straight above, you're getting those direct rays. So, what does that mean for a daily march of temperature? Well, during the day will start off cooler, right, in the morning, and then it'll warm up, and then it will cool off, all right? All connected to the sun. There's a similar annual march of temperature where, you start off your year, it's cold. Right now, it's cold. And then it warms up, and then it cools off. And, there's, of course, ups and downs. There's, you'll have your weather systems. For example, it's been raining even though it's January, which is a little crazy, but I have to admit that I like it warm. So, these are the things that happen every year, every day. And there's an annual lag of temperature. Well, why is there a lag? Why is it often that the coldest month will be February instead of January? Well, in a nutshell, it's because our atmosphere is absorbing that warmth, and then it releases it, right? And so, looking at the season, you'll have really, really warm August and July, for example, even though that's after when the sun is at its brightest. Same thing happens for the day. I'm running up to 10 minutes here, so I'm gonna have to switch off and start another one here.